thing, guys. I've seen people do it wrong. Listen up, because I'm afraid you're going to miss it on the test. So, seeing people solving this, you should not be solving. There's no equal sign. So I don't know why we're solving. We shouldn't be solving. So it says find f of g of x. So we know that that's f composed of g of x. So we would rewrite it as f of g of x, right? The function f composed of g of x. So we locate g of x, ding, ding, ding. We plug it in for function f wherever there's an x. So we have the square root of, anytime I make a substitution, I like to use parentheses, x plus 3 over 4, and then we have our plus 2 and our minus 1. Did everybody at least get that far? Yeah. So then from there, what we're going to want to do is only simplify it to an extent. So really what we should probably do, guys, to be safe, didn't we need to state the domain and range? So I want you to think back to rational functions. If we have x minus 3 over x minus 3, and I say simplify and state the excluded values, don't you need to state the excluded values before you simplify? So x cannot equal 3, and then we can simplify. We need to do the same thing here. Before we simplify, we need to look and state the excluded values. Does that make sense, everybody? So we would say underneath here, all that stuff. So we have x plus 3 divided by 4 plus 2 needs to be greater than or equal to 0. Is everybody following me? Yeah. So let's solve for that value of x, subtract 2. So we have x plus 3 over 4 is greater than or equal to negative 2. Then we multiply by 4, correct? So we have x plus 3 is greater than or equal to negative 8, and then we'll subtract 3. So we have x must be greater than or equal to negative 11. So that means our domain is negative 11 to positive infinity, correct? So that's just one thing to remember. Domain is negative 11 to positive infinity. I didn't specify, so either or would have worked. We usually like interval notation. Good question, though. Okay, so now we can simplify our answer. This is f of g of x. Let's simplify it. So what did you get underneath the radical here? The square root of, did everybody get x plus 11? And then over, okay, over 2. Does everybody see how I got that? They got a common denominator. Then on the bottom was a 4. They split at the top with the bottom. The square root of 4 is 2. And then we have our minus 1. Okay, so I'm glad you said that, so we can go through it. I'm sure there's others that have no idea, so we should probably just go through it. So we have time to go through it. Let's do. So we would say, okay, we have the square root of, this is really x plus 3 over 4 plus 2 minus 1. Let's combine those. Don't we need a common denominator? Over 1, so we'll multiply by 4 over 4. So we have the square root of x plus 3 over 4 plus 8 over 4. Now we have a common denominator, so that's the square root of x plus 11 all over 4 minus 1. So then we just learned this the last time. If we have a square root, well, was it last time or a couple times ago? We can split it up and say that's the square root of 11, x plus 11 over the square root of 4. Right? Same thing as having them both under here, minus 1. So simplify that. We have the square root of x plus 11 over 2 minus 1. So, does that make sense? Yeah. Okay, good question. Now, what I'd like to see, because I've seen a few people do it in my other hour, we could technically rewrite this even prettier. Isn't this technically y is equal to 1/2 the square root of x plus 11 minus 1? We want it to be really pretty, right? Anything divided by 2 is the same thing as multiplying by 1/2. Okay, awesome. That is our answer, and we already stated the domain. Questions? Okay, awesome. So let's get started. Okay, this is our last lesson of the unit, so next time we'll be reviewing, and then the next time we'll be testing. Okay, here we go. So, yep, So 4-5 is inverse function. So we did 4-6 last time. We learned how to graph radicals. Now we're doing 4-5, inverse function. Now, for me to be able to teach you, and don't talk when I'm teaching. Okay, so let's first just talk about a couple things with functions here, because we need to get some deep understanding a little bit about inverse functions. So let's just talk about a function. We know how functions work. If you input something into a function, you get an output, correct? You get something out. You plug something into a function, you get something out. So our input would be what we put into our function. That'd be the domain of our function, correct? We already know this. And we get something out, and that would be the range of our function, our y values or f of x values. So if we have a function, and we have some inputs here, we know that's our domain, correct? So if we put x equals 2 into our function, and we get y equals 3, that would be our output, our range. Correct, everybody? Thanks. Okay, so what our original function did was it mapped 2 to 3. What an inverse function is going to do is map 3 back to 2. So I'll say that again. Our original function took and mapped 2 to 3. What an inverse function will do is map 3 back to 2. So, with that being said, if we have an xy point, then our inverse function will have a y comma x point. Does everybody kind of understand that? Didn't I just switch x and y? Correct. Yep. So now, so we plugged in our original, we had x equals 2. We got out y equals 3. Our inverse function will be plugging in x equals 3, and we'll get out y equals 2. Does that make sense? Your inverse function, if you have a point, so let me write this out once more. If we have a point on our original function, was it, 2 comma 3, then our inverse will have the point 3 comma 2. Yeah. Okay, awesome. Okay, so I want you guys to tell me, what is the inverse of this relation? Now this is a relation, meaning it's just a set of xy points. You guys tell me, what is the inverse of this? So you're going to be telling me x comma y inverse. What is the inverse? Write it on your whiteboard. So I want you to notice something. This is our domain of our original function, correct? Yeah. Isn't that the range on our inverse function? So the domain of the original function is the range of our inverse function. Very interesting. And look at this. The domain on our inverse function is the range on our original function. Is everybody seeing that? Okay. What I want you to do now is graph both the function and the inverse. And see if you can notice anything in particularly interesting about a function and its inverse. All right, so you guys were able to notice that these points, so this is our inverse, the purple points are the inverse, the black points are the original function. You were all able to see, yes, these are a reflection over the line y equals x. So an inverse, if you graph it, and you graph a function and its inverse, it'll be a reflection over the y equals x axis. Does everybody understand? Okay, awesome. So we've just learned a couple things about inverses. First of all, if we have a set of xy points, then its inverse will have y comma x points. And we also learned that it's a reflection over y equals x axis. Okay. Awesome. So now we're gonna find the inverse algebraically. This is how you do it. So just so you know, we're going from f of x, the original function, to our inverse. That -1 is how they write inverse function. Just f -1 x. That just means f inverse of x. So this would be how the notation looks. So these are the steps you use to algebraically, given an equation, find the inverse. You first switch x and y in the equation. So originally we have y equals 2x plus 7. We switch x and y. So we'll write x is equal to 2y plus 7. Second, all you're doing is solving to get y alone. So we're trying to get it in the form of y equals a function. So we would subtract 7, correct? And then we would divide by 2, and y's alone. That's when you know I'm done, I found my inverse. Now our third step is simply changing it to the correct notation. Instead of writing y, write f inverse of x, just so that we know that you're talking about the inverse function of the original f of x. So pretty easy steps here, right? Algebraically is pretty easy. So do I need to leave that up or are we good to go? So I want us to go ahead and find the inverse algebraically. I want us to graph both and then we're going to look at the domain and range on each and see why it all makes sense so that you can then not have to graph all of them in the future. Okay, so let's do this one. So our original function is x squared minus 1. So let's find the inverse algebraically. So we have, okay, let's do this. So that's technically y is equal to x squared minus 1. Our first step is switch x and y. So x is equal to y squared minus 1. Now we're solving for y, so we're going to add 1 to both sides. X plus 1 is equal to y squared. We're solving for y, we'll now square root both sides of the equation. Now we can't forget, when doing this, when we're technically solving here, so we cannot forget that it's really plus or minus the square root of x plus 1 equals y. So our inverse function, I'm going to write it correctly, f inverse of x was equal to plus or minus the square root of x plus 1. Okay, so I'm going to box around that so we can keep focused. Okay, so let's graph the original function. I'll graph the original function in purple here. So we know how to graph a quadratic that's shifted down 1, so we go down 1. And so we can plot points here. So I'm graphing my original f of x. And now let's graph the inverse. I'll graph that one in red here. So let's think about, we just learned how to graph this, correct? Yeah. It's going to shift to left 1. So we're going left 1 here, okay? Now let's graph these separately. This is positive square root of x plus 1. So that would be up 1 over 1, up 1 over 3, like just graphing the positive, right? So up 1 over 1, up 1 over 1, 2, 3. So we have that piece. But also we have the negative, the reflection of that. The negative is a reflection, remember? So that's going to be also a reflection over the x-axis. So we also have this piece drawn. All right, that's our inverse function. So my question for you is the inverse of this particular function, is the inverse of function? No. Why not?
Because some inputs have only one output.
Good. This input 4 has 2 outputs, correct? With 2, it has 2 outputs. Oh, there's a lot of places that x value has 2 outputs. Does everybody understand? That is not qualified as a function. It doesn't pass the vertical line test. If I go like this, it hits my pencil twice in one x spot, that's not a function. So that will happen at times when your inverse function is not a function. So I'm just going to make note of that. It's not a function. Okay, awesome. So now once again, looking at this, it looks right, correct? Here's my the line we should be reflecting over. It looks like, let's check some points here. This is point over 2 on the original, over 2 up 3, correct? So won't the inverses be 3 up 2? Wait, did I say that wrong? Over 2 up 3, so then we'll be over 3 up 2. Perfect, and there is that point. Is everybody seeing it? It's all making sense. And look, there's the reflection over the y equals x axis. And there's that, those two are reflections, correct? And those two? Okay, sweet, and then those two. Okay, just making sure we all understand. Okay, let's look at the original function and do the domain. Now, domain is the easiest. Let's look at the equation. Honestly, guys, we know how to do domain really well, so what I like to do is find the domain on both, and then we know the range on the others, because the domain of the original is the range on the other. Does that make sense, everybody? Because we know how to look at domains very, very quickly. We've had tons of practice with this. So looking at the original function's equation, let's not use the graph, let's use the equation. What's the domain of x squared minus 1? What's the domain of a quadratic, you guys? Negative infinity to positive infinity. Okay. Okay, so what will my range be on my inverse? Yep, negative infinity to positive infinity. Now I like to say, like I said, I like to focus in on domain. So let's look at the inverse's domain. I'm going to look at the function. So what is the domain? -1, because that has to be greater than or equal to 0. So -1 to, good, -1 to infinity, bracket, parenthesis. So our range on our original is also -1 to infinity. Let's look at our picture, our graph, and see if that's true. So the domain on the original, yep, we're good. The range is -1 to infinity. It worked out. And let's look at our inverse. The domain is -1 to infinity. That one worked out, the red thing. And then our range is -infinity to positive infinity. So it all is making sense here. Any questions? Okay. Sweet. So just really quick up here, let's quickly go through this and I'll just let you practice. Let's find the inverse of this function algebraically. And then tell me is the inverse of function. So we would switch x and y. So x is equal to y cubed. Solving for y, what would we do? Cube root it. So we have cube root, cube root. So our inverse, f inverse of x is the cube root of x. Is that a function? Is the cube root a function? What do cube roots look like? So it passes the vertical line test, right? There's only one x value to every y value. So this one would be a yes. Okay. Awesome. Let's do this one. We have x is equal to 3y squared over 4. Solving for y, we would first multiply by 4. For x is equal to 3y squared, we divide by 3. So we have 4x divided by 3 equals y squared. We'll square root both sides. So f inverse of x is plus or minus the square root of 4x over 3. Is that a function? No, isn't that this looking thing? Once again, a square root function with a positive and negative halves. So that would be no. And then we could go through and do that one. You guys go through and do that one on your whiteboard. Then we'll just continue upward and onward. So you guys tell me what the inverse is and is it a function? So shout out your answer. Inverse, f inverse of x was what? Plus or minus? Square root? 5x? Okay. Divided by 2. Is the inverse a function? Nope. Plus and minus, a square root would look like this. So no. Sweet, you guys totally get it. So what I want you to do is 1 through 16 on the worksheet. On problems 5 through 16, it is honestly the hardest part for people is stating the domain and range of the function and its inverse. So go through and do that. Remember, I like to personally find the domain of both and then we know the range of the others. Very carefully. This is where it gets a little bit, just takes a little bit deeper of thought. Okay, those are very, very straightforward. So let's consider the function f of x is equal to the square root of x minus 2. Notice we haven't practiced finding inverses yet of any square roots. We found quadratics and then found the inverse of a quadratic. We haven't found the inverse of the square root. So it says, what's the domain and range of the original function, and let's find the inverse. So let's go ahead and talk about looking at this. What's the domain? 2 to infinity. Is everybody following with y? This must be greater than or equal to 0. Okay, our range. We know how this graphed. So this is shifted up and down 0, correct?
Yeah.
Not quite. So this is right 2, correct? So what's my range? 0 to infinity. Okay. Does everybody understand? Okay. So let's go ahead and algebraically find the inverse here. So we have x is equal to the square root of y minus 2. First step would be 2. Square both sides. Yep, good. Square both sides. So then we would have x squared is equal to y minus 2. Then we add 2. So we have x squared plus 2 equals y. So there's our inverse. F inverse of x is x squared plus 2. Let me graph that for you. Okay. Look at the original function and the inverse. Something's weird, right?
Yeah.
What is weird? Okay, Allison's got it. So there's both sides, but there wasn't on the original. So this is technically not quite the inverse, correct? What would I need to do? Yeah. I can see where you're both going with that. Anyone else have any other idea? So, isn't this the inverse, but only on a certain interval? I'll say that. Isn't this, yes, the inverse, but only on a certain interval for x? That was a better question. So, which interval? Not quite. Remember, this is the reflection over the y equals x axis, correct? Ding, 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 ding. So this is over 2 of 0. This will be up to over of 2 of 0, right? Okay, so only this half, the positive x 0 to infinity, this is the inverse of. Does everybody, this is the inverse, but only on intervals x values greater than or equal to 0. So we would have erased that. Does everybody understand? So that's, to make sure you state the true inverse, you've got to really think about this. So basically, if you're finding the inverse of a square root function, it's only going to be on a certain interval for x that you actually find the inverse of. Here's why. This is not plus or minus the square root, correct? Okay, so does everybody understand? Sweet. So let's find the inverse of these. So do some more advanced ones. Well, these aren't that advanced. A couple few of you. Okay, so let's see what we get algebraically. We switch x and y. X is equal to the square root of 2y minus 1 minus 2. So we added 2. X plus 2 equals the square root of 2y minus 1, correct? Square both sides. So we have x plus 2 squared equals 2y minus 1. Understand? On an inverse, I don't expect you to multiply that out and put it in standard form. It's not wrong if you did, but you would not be expected to do that. Add 1. So we have x plus 2 squared plus 1. In fact, this is even prettier because then it's in shifted form, really. Equals 2y. So then we would divide by 2, correct? So I like what I'm seeing here. We technically have f inverse of x. Let's write it all pretty style. That's 1/2. And then x plus 2 squared plus a half. Yes. But that's not it. That's not it. Okay. Guys, our inverse is a full quadratic. Was that a full top and bottom square root? So that is not the true inverse unless I say what interval of x it is the inverse over. That's what we just talked about. So this was the positive square root, correct? So it will be the inverse on the interval from x is 0 to infinity. So we would say this is our inverse, but you have to state this part. For x values greater than or equal to 0. That's the correct answer for the inverse. Okay, you guys wanted domain and range. Let's do the domain and range. Okay, let's do the domain of both. Guys, the domain should be easy for us to see. So let's look here. Of the original function, what's my domain? 1/2 to? Yep, so our domain on this is 1/2 to infinity. Okay, sweet. Then what's our range on our inverse? 1/2 to infinity. And then let's look at the domain on my inverse. Good, 0 to infinity, right? Oh, yeah. Even though it is a quadratic, it's only a quadratic on that interval. Yes. Good question. Let's picture the graph of this, roughly. So we factor out 2. That one wasn't a pretty one to graph. So let's type it into your calculator and see where it kind of ends up here. Okay, let me finish this back and then we'll answer that question. Okay, so then once again, my domain on this one was 0 to infinity. So 0 to infinity. So then my range on this, oh, I see what you're saying. Yeah, you've got a vertex. We've got a shift. I did not mean to say 0 to infinity. Actually need to fix this. Sorry about that. I am super glad that Zach caught that. So it was, if it was not shifted, it would have been 0 to infinity, but now it's left 2. So that's -2, correct? Greater than or equal to -2. So our domain will be -2 to positive infinity here. And so our range on here is -2 to positive infinity, which makes sense, it was shifted down too. Does everybody see how it's all making sense? Sorry, I'm so glad Zach fixed that. Okay, sweet. Let's do these two. Do you want to give it a shot by yourself?
Yeah.
Find the inverse. These are more difficult, algebraically. You try the second one to see if that helps. So x is equal to 2 over y minus 1. So what Zach did right here, he multiplied both sides by y minus 1. So you multiply by y minus 1. Let's throw it in parentheses, y minus 1. So then it divides out on this side. So we have y minus 1 times x equals 2. Or remember, your goal is to solve for y. So my next step would be to get rid of x. Then we would add 1, so our y inverse is 2 over x plus 1. Domain and range on both of these should be really simple. So the domain on this is 1 to infinity. So the range on this is 1 to infinity. The domain on this is 0. X not equal 0, correct?
Yeah.
Right? And then, so yeah, we could do that. Okay, see if you can do this one.
Gotta get x to have the same.
Okay, before we go through that one, look up here because Rachel made a good point, and I went, oh yeah, I'm sure that a lot of people don't realize that. Okay, so what's the domain on this? We decided it's what? That's wrong though, right? Isn't it okay to have a negative on bottom? Right? Yeah, no, absolutely. Absolutely. So Rachel, it hit me that I wasn't saying that correctly. We just can't divide by 0, right? We can divide by a negative though. So isn't it every value except for 1? So negative infinity up to 1. Parenthesis, parenthesis, and then 1 to infinity. So that'll be our range here. Yeah, union, I just couldn't fit it. And then union, 1 to infinity. And then the domain on this one would be negative infinity up to 0, union, 0 to infinity. Is everybody good with that? So then that's our range here. Okay, let's go through this one algebraically. There will be one like this on the test and on your homework. So you switch x and y. So we have x is equal to y minus 3 over y plus 2. Now, all of you have the right idea to start out with. Let's get rid of fractions, so you multiply by y plus 2. Okay, now what I would do was multiply x in, because I'm seeing I have y. Okay, I need only one y, so I want both my y's on one side of the equation, so then I could factor out a y. Is everybody seeing where my mindset was going with that? So let's distribute x through, so that's xy plus 2x equals y minus 3. Now, once again, I have a y over here, a y over here. Let's get all the y's on one side of the equation and everything else on the other side. Subtract 2x, add, subtract y, sorry. So on this side, I have xy minus y equals negative 2x minus 3. Now look, I have all my y's over here, so I have two terms. I can factor out a y. So left will be x minus 1. Then we would, last step to get y alone. Y is now alone. There's our inverse, f inverse of x. Good. So once again, this domain and range, make sure we don't confuse it with underneath the square root, right? We can't have a negative, just making sure we all remember. Okay, yes. Domain and range of both would be good. So I always find the domain of the original, domain of the inverse, and then we know the ranges of it. Okay, so I'm going to have you do a couple, and then I'll bring you back to me one last time. So go to the back page 23 through 31, where you have some square roots that you're finding inverses of. Make sure you restrict the domain accordingly. Everybody listen. Okay, so I'm going to read this to you because you're going to see the word one-to-one, and you need to know what it means. So you know that for any function f, each x value in the domain corresponds to exactly one y value in the range, correct? We know that. That's what makes it a function. It passes the vertical line test. It says for a one-to-one function, it is also true that each y value in the range corresponds to only one x value in the domain. So a one-to-one function has wait, sorry, I didn't read that very good. A one-to-one function f has an inverse f that is also a function. So if f maps a to b, then f inverse must map b to a. So basically, this is what will make it one-to-one. Are you ready for me to put it in simpler terms for you? If both the function and its inverse are functions, it's one-to-one. Does everybody understand? So you know all those ones where you said no to, it wasn't a function, the inverse. That would be considered not one-to-one. Does everybody understand? Okay, awesome. Now this is the other thing. So this is what's going to happen. I'm going to put it in basic terms for you. If you have f of x and f inverse of x, if we did a composition of functions, so if we did f of f inverse, then you're going to simplify that and get x if they're truly inverses of each other. Does that make sense, everybody? So also, if you do f inverse composed of the original f of x, you better get x, the identity function x. So you got to check both, but if you test something and it's inverse and they both simplify, you compose f of f inverse and you compose f inverse of f and you both get x, then they're inverses. So you will be expected to do that algebraically on the test. So let's practice. Here we go. So it says for f of x, 1 is equal to 1 over x minus 1 is g of x, 1 over x plus 1 the inverse. Algebraically show me. So what you'd be doing is, say, I'm going to algebraically do f of g of x, and I'm also going to do g of f of x. And I'm going to simplify both of those, and if we get x, then yes, they were truly inverses. If you don't, then no. Ready, go. So I'm starting to do f of g of x. So I took g of x, this one, and I put it in here wherever there's an x. So we have 1 over this, yeah, minus 1, and they are. You've got to be able to do this correctly algebraically. So everybody watch, because there's going to be some algebra here that you have to do. So we know this is really 1 over x, and then those are 0, right? Dividing fractions easy as pi, you flip the second fraction and you multiply. So we're really looking at this, 1 over 1 divided by 1 over x. So we really have 1 over 1 times x over 1, which is x. Check to that. Let's do this one, g of f of x. So we're putting f of x into g wherever there's an x. We have 1 over x minus 1 plus 1. So we have to simplify. Division comes first. So that's dividing fractions easy as pi. We flip the second and multiply, right? So we technically have 1 over 1 divided by 1 over x minus 1 plus 1. So we flip the second and multiply. So that's x minus 1 plus 1, which is x. So they are truly inverses of each other. Everybody good with that? If you didn't show it this way, you would get it wrong on the test. Okay, you guys verify that these are inverses. Go. Let's see who's really thinking. Can anyone tell me what the answer is right off the bat? Given f of x is equal to 3x, what's f o f inverse of 2? Way to go, you guys are so fast. How do you know that? Good, we're plugging into. Very good. Okay, awesome. Very easy. So you don't have, I mean, yes, the next 10 minutes I need you doing a couple off the worksheet, maybe check some of the story problems. Am I good with this? Ask for help. You do what you want to do to be prepared for your online homework and the test review.